Hey guys, welcome to Unit 3, Lesson 4, where we're going to be talking about x and y intercepts. So you're probably thinking, I already know what y-intercepts are. We've been talking about them with slope-intercept form. Yes, you have. The y-intercept is that point at which the line intersects the y-axis, which we identified as b in y equals mx plus b. But we're going to talk specifically about both the x and y-intercept today. So the x-intercept is the point where the line intersects the x-axis. And the y-intercept is the point where the line intersects the y-axis. Okay? So on the graph shown to the right, identify the x and y intercepts of the graph shown. Well, let's identify them first. The x-intercept is where the graph crosses the x-axis, which is at that green point. And the y-intercept is where the graph crosses the y-axis at that y point. And let's talk about these ordered pairs. An x-intercept, since it is where you hit that x-axis, the y value of that coordinate will always be 0. So the coordinate of the x-intercept will always be an x, 0. And the coordinate of a y-intercept, as we've spoken before, since it is crossing the y-axis, it's always going to have a coordinate that reads 0, y. So 0, y. So specifically in this line, I need to zoom in so I can see here. Specifically in this line, the x-intercept is, let's see, what point is this? 1, 2, 3, 4, 5, 6, 7, 8 is 8, 0. So there's my x-intercept at 8, 0. Or I have what we call an x-intercept at 8. And my y-intercept is at 0, let's see, this is positive 1, 2, 3, 4, 5, 6, 7, 8. Oh, also 8. My y-intercept is at 0, 8. So I have we can also say a y-intercept at 8. We can say a y-intercept at y equals 8. And x-intercept at x equals 8. There's so many different ways to say the same thing. But as an ordered pair, the x-intercept is x, 0 or 8, 0 for this line. And the y-intercept is 0, y or 0, 8 for this line specifically. Note that a line cannot have more than one x-intercept. There it hits the x-axis. It's going to go on forever. It'll never hit the x-axis again. And a line cannot have more than one y-intercept. It's going to hit the y-intercept, the y-axis there, and it's going to go on forever. There are certain lines that can have no x-intercept or no y-intercept, which we'll talk about when we talk about horizontal and vertical lines, guys. So how do you find the x and y-intercept if you're not given the graph? If you're not given a visual picture of the line, how do you find that x and y intercept? So we can find the x and y intercepts algebraically. And here's how you do it. So let's talk first about the ordered pair of the x-intercept. Remember that the ordered pair of the x-intercept is always x, 0 because it lives on the x-axis. That point on the line is going to live on the x-axis. So to find the x-intercept of an equation, you make y equals 0 and solve for x. So let's look at that ordered pair. Make y equals 0 and solve for x. That's going to give you that ordered pair that is the x-intercept. Make y equals 0 and solve for x to find the x-intercept. To find the y-intercept, well, let's go back to the ordered pair of a y-intercept. That's 0, y. So we make x equals 0 and solve for y. Okay. You also can find the y-intercept easily if your equation is in slope-intercept form. So that's another trick. If your equation is in slope-intercept form, your y-intercept is b. But if your equation is in standard form or any other form, because there's another form coming up later, if your equation is in standard form, then you need to follow this format. Now the format is coming from the fact of the ordered pair. Since the x-intercepts ordered pair is x comma 0, then we need to set y to 0 to solve for x, for the x-intercept. For the y-intercept, we want to set x to 0. We're going to blank out x, make it equal 0, and then solve for y. So let's try one. Here we have the equation y equals 3x plus 6, and we want to find the x and the y-intercept. Let's go ahead and find the x-intercept first. Remember that the x-intercept comes from a coordinate like x comma 0. So to find the x-intercept, you make y equal 0 and solve for x. So I'm going to label here, we're going to find the x-intercept first. Let's make y equal to 0. So instead of y equals 3x plus 6, we're going to write 0 equals 3x plus 6. That just like that, I just made y equals 0 because we are looking for that x-intercept. So let's solve for x by subtracting 6 on both sides to 0 that out. I get negative 6 is equal to 3x. Divide both sides by 3 to get that x equals negative 2. So I have an x-intercept at negative 2 comma 0. That's my x-intercept. Now my y-intercept, you can find it by making x equal to 0, or you can take a look and see that this is in slope-intercept form. So it's already written as y equals mx plus b. So my y-intercept is right here at positive 6. So 0 comma positive 6 is my y-intercept. So let's bring it down to example number 3, which is pretty similar to the example we just did. This is written in y equals mx plus b format and slope-intercept form, so we can quickly see our y-intercept of 2. So we will write that y-intercept at 0 as 0 comma 2 to represent that that is the ordered pair where the graph crosses the y-axis. Now we're going to find our x-intercept, and we're going to find our x-intercept by making y equals 0 and solving for x. So 0 equals negative 4/3 x plus 2, make y equal to 0. That will help us build the ordered pair x comma 0. And now let's solve for x. So subtract 2 from both sides. Negative 2 is equal to negative 4/3x. Multiply by negative 3/4 to both sides. Cancel, 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 cancel. And we get that x is equal to positive 6/4, or 3/2. So since x is equal to 3/2, our intercept, our x-intercept, is 3/2 comma 0. On the next page, you're going to see equations in standard form. And now that they're in standard form, we can't just pull the y-intercept like we did when it was y equals mx plus b. So now we have to actually work on both of them. So let's take a look at number 5. In number 5, we have 3x minus 2y is equal to 12. And I need to find both the x-intercept and the y-intercept. So I'm going to kind of split my paper up here. Let's work on the x-intercept first. To do that, I want to set y equal to 0 and solve for x. So 3 times x minus 2 times 0 equals 12. Made y 0. Now let's solve for x. So 3x minus 0 equals 12, or just 3x equals 12, which means that x is 4. So my x-intercept is 4 comma 0. Now let's find my y-intercept. Find my y-intercept by making x equals 0. 0 out, not 0 out, but like you make x have a value of 0 so that you can focus on the y. Because our ordered pair for a y-intercept is 0 comma something. So 3 times 0 minus 2 times y is equal to 12. 3 times 0 is 0. Minus 2 times y is equal to 12. So that 0 just disappears and we end up with minus 2y is equal to 12, or y is equal to negative 6. So that's my y value when my x value is 0. So 0 comma negative 6. And I found my x-intercept and I found my y-intercept. There's so many reasons why we need to know how to find x-intercepts and y-intercepts, and you use it so much in algebra moving forward and more advanced courses in algebra. And one of the reasons is to be able to graph using intercepts. So we've talked about how to graph equations when they're in y equals mx plus b format, which is easy to do. You grab your slope, you grab your y-intercept, and you know how to do the rest of the job. But what if our equation is in standard form? Now I know you're probably thinking, well, if it's in standard form, I'm just going to switch it into y equals mx plus b and go for it that way. But now that you know how to find intercepts, you can graph using the intercepts. Keep in mind that it only takes 2 points to make a line, and the x and the y-intercept are 2 points on the graph. So if we found the x and the y-intercepts, we could use those 2 points to graph as well. So it's just another way to graph a line, another tool for your toolbox. So let's take a look at number 7. We have x plus y equals 3, and we're being asked to use intercepts to graph. So my x-intercept can be found by setting y equal to 0. So x plus 0 is equal to 3, or x equals 3. So my x-intercept is 3, 0. My y-intercept could be found by setting x equal to 0. 0 plus y is equal to 3. So y is equal to 3. So my y-intercept is 0, 3. I'm going to plot those 2 points. So here's 3, 0, and here is 0, 3. And I can now graph that line between those 2 points, and there is the line. I graphed it using the x and y intercepts that I found algebraically. Didn't have to convert this into standard form, into slope-intercept form, and got another way to graph a line when my equation is in standard form. So let's try one more together. Let's try number 10. So they want us to graph, or they've asked us to graph using intercepts. So first let's find my x-intercept by setting y equal to 0. So 2x minus 0 is equal to 7, or 2x is equal to 7. So x is equal to 7 over 2, which means my x-intercept is 7 over 2, 0. My y-intercept is found by setting x equal to 0. So 2 times 0 minus y is equal to 7. So minus y is equal to 7, or y is equal to negative 7. And there's my ordered pair for my y-intercept. Now this is a situation where it's kind of annoying that our x-intercept came out as a fraction. So we are kind of going to guesstimate, but it is 3.5, so that's not too hard. 3.5 is right in the middle here. 3.5, 0, and 0, negative 7, which is here. And then we'll graph the line between those 2 points. Oh, I am off there. Well, forgive me. My line is a little bit off. And now I have graphed the line of 2x minus y equals 7 using intercepts. Go ahead and try 8 and 9. And if you have any questions, self-correct them using the answer key on Canvas. And if you have any questions, mark it up, submit it at the end of this video, or be ready to ask it in class. Thanks for watching, and thanks for learning.